Right, welcome to today's lesson on logarithms. Today we're going to show you a very short lesson on what a logarithm is, or log as called, and you'll be able to see that the logarithms are exactly matched to what we call exponents, indices, or powers. Now the logarithm or log of a number is simply thought of this. What number, when raised to a certain power, will give me a certain number? That's a hypothetical question. And so what we could have, for example, if I were to find the answer to this particular question, 2 to the power of x is equal to 10. Now, we know, for example, that 2 to the power of 0 is equal to 1, 2 to the power of 1 is equal to 2, 2 to the power of 2 is equal to 4, 2 to the power of 3 is equal to 8, 2 to the power of 4 is equal to 16. Now, we can safely assume, if we look at the number 10 here, that we could safely assume that 10 is closer to 8 than 4. That makes sense. So it's got to be a number between 2 to the power of 2 or 2 to the power of 3 to get the 10. In fact, it's got to be a number between 2 to the power of 3 and 2 to the power of 4. My apologies. Let's just compare 8 and 16, not the 4. So this has to be a number that is close to 8. This has to be a number that is close to 8, but not as close to 16. So some number where x is between 3 and 4. So it's got to be a decimal or fraction of some sort. So because most people cannot figure out in their heads what the power of 2 would be to get to 10, I need to use what is called logarithms. Yes, we know that, for example, when you come to exponents, 2 squared is equal to 4. So I know 2 has to be raised to the power of 2, or exponent 2, to get the 4. But certainly in this type of question, that is not the same thing. So what I need to do, I need to take logarithms, or take the log of a number. Excuse me. Take logs to find x. And that's really important. So what I need to do is the following. I need to then go to the definition of the log, which I'll come to in a minute. And so the definition of a log would look like something like this. It would be the following. Base number 2, logarithm 3, number 8. Now the log of a number is the power to which the base must be raised to give the number. Let's say it again. The logarithm of a number, this 8 is the number, so I need to find log 8, for example, is the power to which I raise the base. The power is 3, or the exponent is 3. I'm raising the base 2 to the power of 3. 2 to the power of 3 equals 8. And that is my definition. So to come back to my original question over here, if 2 to the power of x is equal to 10, and I need to take the logs of both sides to find x, then I need to say, therefore, log 2 to the power of x is equal to log 10. By the logarithm laws, x log 2 is equal to log 10. In fact, the log laws are just the exact opposite of the exponent laws I shared on my other video called Exponential Functions Simplifying. And so what I do is I take logs on both sides, as you can see there. Therefore, x is equal to log 10 over log 2, log 10 divided by 2, log 5 and you would get that answer on your calculator, and you would then certainly look that up on your calculator. Now, I'm not going to show you your calculator because everybody has a different calculator. But what you do is you go to your calculator, whether it's a T183, it's a Casio FX, or it's a T-Inspire. Press the log button on your calculator, it'll give you that answer. And that answer would be the number you use where 2 is raised to the power to give me 10. That answer is the number you use with 2 to the power of that number to give me the number 10. And I think we've got some understanding of logarithms so far. So let's say the question says evaluate. Let's take this out here. Evaluate log 27 to the base 3. Notice this is my base or base number. And if the base number is not written down, then you assume it's base 10, because as human beings we count in terms of tens. That's our decimal system, tens. Now the very important thing you have to do is to make sure that you postulate it equal to the value of x. Most students don't know this, and most textbooks will not tell you this. This is a really important clue, because then you can redefine the log. And of course we haven't got our calculator. No calculator allowed. And so what I need to do is define this. If you were to be allowed a calculator, all you would then do is go to your calculator, put in log 27, make sure it's to the base 3, and get an answer. But if we have no calculator, we have to redefine this log in terms of its opposite, its exponents. And I can say in terms of my log definition, the log of a number is the power to which the base must be raised. This is the base 3. That's the base. This is the number 27. And this is the power, or the exponent. Very important. Therefore, 3 to the power of x is equal to 27. See what we did there? We raised this base. We raised the base to a power, which is x. The base number 3, 27. In my previous videos, I shared that when you have a number that's not prime, always look for the prime number. And you have to think to yourself, one number when divided by will go divided into 27, excuse me. And that number would be 3. And so knowing your prime number is 3 to the power of 3. And in my previous videos, I shared how to solve that. My previous videos are called exponential functions simplifying. And so then we would have the same base 3, therefore x is equal to 3. And of course it would be this green 3 over here, which we are now solved for. Right, good luck and hope to see you again. Bye-bye.